This is Hubwonk. I'm Joe Selvaggi. Welcome to Hubwonk, a podcast of Pioneer Institute, a think tank in Boston. The 2021 United Nations Climate Change Conference, the 26th Conference of the Parties, also known as COP26, is being held in Glasgow, Scotland between October 31st and November 12th. Leaders from around the world are meeting to coordinate policies to address the dangers of climate change. But policy choices are being largely based on the scientific findings compiled in the Intergovernmental Panel on Climate Change Reports, most recently released in August. This report was characterized by many leaders, such as UN Secretary General Antonio Guterres, as a, quote, code red for humanity, going on to say that the alarm bells are deafening and the evidence is irrefutable. Greenhouse gas emissions are choking our planet and putting billions of people at immediate risk. But does the newest IPCC report actually support such a dire outlook? Or have political leaders, possibly motivated by desire to catalyze action on climate policy, badly mischaracterized the IPCC's report findings, and in so doing, damaged their public credibility and the prospects for productive climate policy? My guest today is Roger Pielke, Jr., professor of the Environmental Studies program at the University of Colorado at Boulder. Before joining the University of Colorado faculty, he was a scientist at the National Center for Atmospheric Research. Professor Pielke is the author of 8 books, has testified on climate science before Congress, and has contributed articles on climate to the Financial Times and other news outlets. Professor Pielke's work focuses on how science and public policy interact. Professor Pielke will share with us the findings of the most recent IPCC report and discuss in what ways it has diverged from its own earlier predictions. He will also describe the widening gap between scientific observations and the dire predictions made by many political leaders. The theme of Professor Pielke's recent work is that effective climate policy rests on confidence in the integrity of the climate science community. For that reason, science and scientists must not become politicized, and climate policy leaders must adjust their rhetoric to match the reality of newer climate observations. When I return, I'll be joined by University of Colorado professor Roger Pielke, Jr. Okay, we're back. This is Hubwonk. I'm Joe Selvaggi, and I'm now joined by the University of Colorado at Boulder, Professor Roger Pielke, Jr. Welcome to Hubwonk, Roger.
Thanks, Joe. Good to be here.
All right. Well, this is a very timely conversation. This week, 30,000 people, including many world leaders, are meeting in Glasgow to discuss global policy steps to address climate change. I want to talk about the most recent scientific observations on climate change, the data that undergird the decisions at this time. But before we dive into the science, I want to talk about how you came to climate science. You've written 8 books. You've testified before Congress. You've written in articles in Financial Times. You have a fantastic Substack account talking about climate. But what drew you to climate science back in the day?
Yeah, I guess it's in my DNA. My father is one of the leading atmospheric scientists of his generation, and he pioneered 3-dimensional numerical modeling of the atmosphere. And so I grew up, hearing a lot about atmospheric science and climate. I went in the policy direction, and when I did my PhD in the early 1990s, I was looking for a really hard policy evaluation topic. And the topic I picked, which was very niche and esoteric at the time, was how well does climate science relate to climate policy? And really have studied the issue on and off in different dimensions for almost 30 years.
I guess your goal was to ensure that the science informs policy, and they're all on the same song sheet, that there's not a big difference between what the science indicates and what policy makers are using.
Yeah, we want that relationship to work well in 2 dimensions. One is we want science to inform policy, of course, but we also want to make sure that politics doesn't corrupt or undermine the integrity of science as well. So we want them integrated, not separated, but how to do that can be often tricky, particularly on highly contentious topics.
That leads me to my next question, which is, you've seen science, climate science progress over 30 years, and you've said it's gone from a lively disagreement amongst scientists, which is natural, that's the nature of science, to moving more to the front pages of news and political journals. I don't know if you would agree with me, but I read that it was somewhere around 2008, 2009, you saw an inflection point from where we were talking pure science and lively debate on scenarios to something a little bit different. Can you describe to our listeners what you saw in 2008, 2009 as a shift?
Yeah, I mean, the first thing to say is that the core findings of climate science have been remarkably strong and consistent since at least the 1980s, when the IPCC, Intergovernmental Panel on Climate Change, was first created. That humans affect the climate system. Those effects can cause serious risks, and we should definitely take some steps to do something about it. That hasn't really changed over time. What has changed is how that science gets overlaid on politics, policy, the media, and the public debate. And really, the shift that I experienced and saw in this issue was more around 2006. It coincided with when Al Gore's movie came out, An Inconvenient Truth. And the idea that in order to gain traction on the climate issue with the public, advocates would have to bring it home to people. And that means to make it relevant to their daily lives. And the way that was done was to associate extreme events, and really every extreme event, hurricane, tornadoes, floods, with climate change, to try to instill in the public mind that that's what climate change is. It's extremes, very media-friendly images of disasters and hurricanes. And that became much more a focus in the years since about 2006, 2007, and generally motivated by a coordinated effort by funders and advocacy groups to bring climate to the public.
So the public is an expert in science, maybe not expert in data analysis, but they know the weather. They see it every day around the world. So that brought it home to the ordinary citizen. Climate change is real, and it's causing, so the inference goes, climate change is causing severe weather events. Is that what you're saying?
Yeah, and it's, I mean, the public and policymakers have always been well out in front of where the science is on that topic. Very, very ready to accept that this or that event was caused by greenhouse gas emissions or climate change. Even when the science was more nuanced and obviously complex than that simple formulation. So it has not been a difficult argument to make in the public's eye. It's just that sometimes the science isn't always there to back that up.
So let's take a step back and talk about the science. As I said, the world leaders are meeting for the COP26 meeting in Glasgow. It's odd to me that they're using the IPCC's most recent data as support for what many are calling code red for planet Earth or for mankind. But in reading your Substack and your articles on the issue, you've read the same report. It's 3,000 pages long. I'll admit I have not read it, but you characterized the most recent IPCC report as having fundamentally a good message, one that is trending more positive rather than indicating the Earth is doomed. Say more about that difference.
Yeah, so the way that the IPCC works and climate science generally is we generate scenarios of the future. The future is an uncertain place, and we can't predict very well what's going to happen in 5 years, 10 years. So we have a wide range of scenarios to characterize plausible futures, and then explore policy options, climate impacts, economic outcomes within that set of scenarios. And the biggest change really in the thinking about scenarios over the last 20 years is that the most extreme scenarios, and by extreme, I mean that the world is going to burn all of the coal that we can find to generate not just electricity, but all of our energy consumption. We're going to take coal and we're going to turn it into liquids and put it into our car. Those scenarios that once were thought where we were headed are now pretty much off the table as plausible futures. So where the world is headed is much less apocalyptic than was thought only 6 or 7 years ago. Now, that doesn't mean that reducing fossil fuel use or getting to net zero carbon dioxide is any easier. It's a huge, enormous challenge. But it does say that we have a future that's a lot less scary than maybe we thought before, even as the rhetoric goes in a different direction.
I want to take a step back and talk about the weather phenomena. Again, we're equating or leaders that are, as you say, out in front of the science, equating global warming with weather. And in particular, again, this is, I think it was the World Health Organization characterized global warming as the single greatest threat facing humanity. Pretty bold statement. There's lots of threats, and this is the worst. If we accept that the world has been warming, I think our listeners may all accept that, at least for the last 150 years. Has this global warming equated to an increase in deaths attributed to climate? In other words, is a warmer world more dangerous for the average human?
So this is an exceedingly difficult signal to tease out because it's not just the climate that changes. It's how we live on planet Earth, where we live, how we build, the procedures we have for evacuation when there's an emergency. One of the most remarkable and underappreciated science, technical policy success stories of the last century is the incredible drop in vulnerability of humans to extreme weather phenomena. Vulnerability has dropped something like 99.75% in a century. It was not uncommon in the 1920s for millions of people to die in a single year due to extreme weather phenomena. Now there's still too many who die, but it's in the tens of thousands, low tens of thousands or less. It's a huge success story. And it's due to science, technology, and things like meteorology, weather forecasting, evacuation, and so on. So if you have a trend from millions to tens of thousands, sharp trend downward, it's very difficult to say, well, deaths are increasing due to climate change. Now, going forward, our progress on reducing vulnerability and the good news on disasters may not continue. There's no guarantee of that. But we do know as a global society how to reduce vulnerabilities to weather extremes.
So we've adapted. I think I read somewhere that as recently as 100 years ago, the average Earthling, member of planet Earth, had 1 in 1,000 chance of dying from a weather event. And now, given the population and the risk, we're at 1 in 400,000 risk of dying from a weather event. As you say, it's a reduction of 99.75%. That's substantial. But what would you say to critics saying that, sure, we've adapted, we've been able to anticipate hurricanes and move inland, but we're at the precipice of an inflection point that suddenly weather will become much more extreme. This is the calm before the storm, to torture a cliche. What would you say to that?
Yeah, and I mean, this is where we go back from the very hot public debate and some of the imagery you see in the media and what politicians may say. Let's go back to the IPCC and see what that projects in coming decades for changes in extremes. And yes, there are some projected changes. Most notably, heat waves are expected to increase, become more severe in many places around the world. But on the other hand, take a phenomenon like drought or tropical cyclones, hurricanes. It will be very difficult to even detect those changes for many, many decades. So the idea that we're on a precipice or we're on the edge of the apocalypse just doesn't stand up when you compare that to the science. But when I engage people on this topic, if they want to believe that that's fine. It's not my job to convince them that they're wrong. But what that should lead to is an agreement among everyone that, yes, we have to keep investing in adaptation, in vulnerability reduction. We have to be better prepared for an uncertain future. So I don't think the policy choices we would make are particularly sensitive to whether one has an optimistic or pessimistic view of the future. We just have to keep doing those things that we know have worked to reduce vulnerabilities to extremes.
You break down extreme weather in your most recent book. I found it interesting and surprising, frankly. In there, you break down which weather events affect human beings or kill human beings, and talk about the trends, whether they're going up or downward. I simply just assumed that events like hurricanes and tropical cyclones were becoming more numerous. Just seems to be that way. That's the narrative. What is your data? Let's just briefly break it down by phenomenon. What's going up and what's going down? You mentioned heat waves. That's going up, but what's everything else doing?
Yeah, and this is a timely question because the IPCC just released its 6th assessment report, a month ago or so, which went through phenomena by phenomena, trends in extreme weather phenomena around the world, and as you say, heat waves have increased. What's called extreme precipitation, and we have to be careful with that because extreme precipitation is a scientific term, that has increased in many places around the world. The IPCC is very careful to say extreme precipitation does not necessarily mean that flooding has increased. And that may be counterintuitive at first, but then you realize, well, here in Boulder, Colorado, if we got an inch of rain today, that would be pretty extreme in the fall. It can happen, but it wouldn't lead to floods. And so that's why the IPCC says with respect to flooding, there hasn't been an overall global increase. With respect to tropical cyclones, there has not been an overall increase in the intensity or frequency of storms on a century timescale. That comes as a surprise to many people. The IPCC breaks down drought into several technical categories, but the types of drought that most people are aware of are what's called meteorological or hydrological drought. And they find one's rainfall and one's surface flows of water, and they find that there are no trends globally in that type of drought. They do find there is a trend in what's called ecological or agricultural drought, which refers to soil moisture. But then we get into phenomena like hurricanes, tornadoes, straight line winds, winter storms, and there is number one, there's not great data everywhere around the world, but the IPCC has not detected upwards trends in any of those phenomena. So when you paint the whole picture, and it's really important to go phenomena by phenomena, because extreme weather is a big bin with a lot of different climatological phenomena. But when you go there, you find that the headline events that we often see in the newspaper, particularly floods, hurricanes, tornadoes, there's not strong evidence of upward trends over climate timescales.
So if there's no measurable trend, attribution is impossible because you can't attribute something to nothing, right?
Yeah, I mean, the IPCC is quite explicit when it comes to attributing long-term, multi-decade trends. And obviously the increase in the global surface temperature has been detected and attributed to human-caused climate change. Excuse me, but you can't say the same for many extreme weather events. That's not at all surprising. Extreme weather events by definition are rare. And so the statistics of rare events are such that it takes a long time to detect changes. So really things are unfolding much as the IPCC has projected. And if you actually do the math for something like tropical cyclones, we wouldn't expect to be able to detect those changes till late in the century, if then, even under some of the more aggressive scenarios of climate change.
So I want to go back to the IPCC, the different scenarios. I think they're called representative concentration pathways, RCPs, and there are different probabilities of different scenarios. You said the most extreme is very unlikely, largely based on the fact that it was deliberately designed to be worst case scenario where everybody burns all the coal possible on planet Earth. Very, very unlikely, but necessary perhaps from a scientific argument perspective. And yet, as unlikely as that scenario is, it seems that in many times that scenario is brought up as sort of the core prediction. You've observed that the IPCC has observed that that's very, very unlikely, and that a different path is more likely. Why do you think policymakers anchor on worst case scenarios that by virtually all standards are highly unlikely or virtually impossible?
Yeah, there's a fascinating story here that gets into things like the sociology of science and communication and so on. But early on, when the climate community said, all right, we need scenarios of the future to drive our climate models, what they said was, well, let's have a low one that has a very low greenhouse gas emissions in the future. Let's have a high one with really high ones emissions, and then let's have a couple in the middle. That was it. There was no consideration of worst case, of likelihood, of plausibility. These were scenarios that were chosen to help support climate research, which is really important, really legitimate, completely justifiable. But when those four scenarios were put into the research community and eventually into published papers, going through university press offices, press releases, media coverage, then finding their way into policymakers' discussions and advocacy. In that process, the most extreme of those four scenarios became represented as the most likely path that we're on, called business as usual. There's a lot of reasons for why that happened, but that is a core, I would say, a core shortfall in how scenarios are used by the IPCC, because no one in that process has responsibility for evaluating the plausibility or likelihood of any of these scenarios. And so as research has gone on over subsequent 10 or 15 years, it's been discovered that this most extreme scenario of the set is highly implausible. And in fact, some of our research suggests that it's already falsified, that the world is so far from it in 2021 that it's not at all appropriate as a guide to the future. So this sets up a very challenging situation for climate research and advocacy, because much of the discussion that we have about the long-term future is grounded in a vision of futures that just aren't possible. And so that makes it really, really difficult, I think, to have a science-grounded discussion of the climate issue, because it's been off track for a while now.
So I want to dig more deeply into why using the wrong scenario is so harmful or potentially harmful. But let's talk about why it's implausible. What has changed in recent years? Let's start at the basics. CO2 or fossil fuels burning create greenhouse gases, and those have some correlation with rising temperatures, and we're going to attribute some, so we're going to say it's causation. But much of the world has changed their energy sources. In the US, we've actually backed away from coal in a different direction. I've read some of your work which says we're already past our peak CO2 output, as is much of the world is approaching this. Is this largely why you're more, let's say, sanguine than the most extreme predictions? Are we trending either in a better direction or in fact downward?
Yeah, so I mean, if one's vision of the long-term future is that greenhouse gas emissions are just going up, 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 it makes the magnitude of the challenge of reducing them, which is already huge enough, it makes it look bigger than it actually is. And it can create a sense of helplessness. And there's studies out there now that say that youth are paralyzed by fear of the future. To say that the future is not apocalyptic doesn't mean that it's perfect and everything we can go about our business and forget about climate change. I'm a policy scholar, and what I teach my students is that if you want to solve a really difficult, complicated problem, the first thing you have to do is characterize the size of that problem accurately. And so I do think it's highly problematic if we have misleading scenarios for the future guiding our policy responses. Now, the counter argument to that is, well, yeah, maybe they're wrong, but if they scare people and they motivate them, that might help the politics of climate change. And then this gets into issues related to the ethics of science and science communication. I'm a stickler for being accurate about the science and having policy justifications that are well grounded in science. The reason for that is we want science to be perceived to be legitimate, and not just today, but for the next 20 years, 50 years. And if scientists are perceived as exaggerating threats, that can't be good for policy or politics.
So those who would perceive it as a noble lie to exaggerate the threat would say it is indeed noble lie, because that's what we need to do to shake the ordinary citizen out of complacency and address this issue. They justify the exaggeration by saying the ends justify the means.
Yeah, we see that a lot. And I mean, that's often how politics works. And I'm not of any illusion that we experts can shape how politicians behave, but what we do have control of is how we behave in the scientific community. And by avoiding the noble lie or trying to campaign based on research we know is dated or flawed, we can help keep the integrity of science solid going forward. And honestly, the science of climate change is robust enough, the futures are scary enough by being accurate that we don't have to exaggerate. We don't need to. And so I see it as an entirely unnecessary debate. And what we should be doing in the expert community is just updating and fixing the scenarios and moving on. And why we have this debate and why people defend bad science is interesting and a story in itself.
Indeed, we both asserted, or you have scientifically asserted, that global temperatures are rising. It's largely attributable to greenhouse gases. So lest we be labeled, either of us, as climate deniers, let's establish that we both certainly accept that trend. So what are the solutions that you've explored, or that the science or the climate science community? We often talk about renewables, wind and solar. To my reading, these are challenging in their own right. There's the physics of the thing. They, the wind doesn't always blow, and certainly we know the sun doesn't shine even there in Boulder all the time. Is this our way out of this challenge?
Yeah, well, first, it's always sunny in Boulder. It's beautiful. So at a very simple level, the answer is yes. And then you start getting into some of the complexities, and the answer is no. It's a lot more complicated than that. But the mathematics are really straightforward, that if we're going to stop the accumulation of carbon dioxide in the atmosphere, our emissions of greenhouse gases in total, but in particular carbon dioxide from the burning of fossil fuels, have to go to zero. And we may want them to go below zero in the sense that we start taking carbon dioxide out of the atmosphere. The only way that we get emissions to go to zero is we replace oil, natural gas, and coal with alternative energy sources. And in my book, The Climate Fix, I call for a stance of technological agnosticism. Once you get into energy technology discussions, you'll find that every energy technology has a constituency. And they think that their technology is the solution, whether it's wind or solar or nuclear or geothermal or carbon capture or whatever it happens to be. And I'm very much of the view that the more carbon-free or low carbon technologies we have on the table, the greater our chances for success. And in fact, as we're learning with the energy crisis in the UK and in Europe, a diversity of supply is a good thing, and not just for climate reasons, but for reliability reasons, for cost reasons, for geopolitics. So when I see the debate on climate change getting wrapped up in the debate over closing nuclear power plants, for example, I think that's a bit frustrating, because nuclear is a good solid option to have on the table, not uniquely, but alongside with renewables and other technologies. When you do the math, you realize that an energy transformation of the global energy system, it's not something that you accomplish in a year, in a decade, even in a couple decades. This is a challenge of a century. And getting to net zero CO2 will be a policy focus, throughout the 21st century. It's not a quick turnaround sort of issue. I am quite optimistic, though, that because it's a technological challenge, humanity's up for it.
You mentioned every energy source has its constituency. Maybe I might put myself in the nuclear camp. I'm perplexed that particularly among those people who are apocalyptic and about the future and see an existential threat to humanity and to Earth. Clearly, nuclear has virtually infinite power potential and zero CO2 emission. Why would the environmental community, maybe this is not a fair statement, but why do they seem to be so reticent to adapt nuclear with both arms?
Yeah, I mean, there's a long history of concerns about nuclear power that goes back to really my parents' generation and folks from the 1960s, with nuclear energy getting wrapped up with concerns about war and weapons. Of course, it's 3 Mile Island and Chernobyl. And every energy technology has risks. Nuclear's risks are what are called dread risks, because radiation and meltdowns are really scary. But when you burn fossil fuels, you put particulate air pollution into the atmosphere, and that creates risks of premature death from bad air quality. It's not as dreadful as a nuclear power plant. So there's a lot of reasons. What I tell people and environmentalists and my students is it's perfectly legitimate to conclude that you're more afraid of nuclear power than you are of climate change, or vice versa. Just realize that when you take nuclear off the table, you have then made the challenge that much bigger to decarbonize the global energy system. But let me say, I think that the debates over nuclear power have taken a turn. Just this week, China has announced they're going to build 150 new nuclear power plants. There's a lot of research going into what's called advanced nuclear energy. So I do think that we will see, in my children's generation and their children's generation, a recommitment to nuclear, because it just offers such a massive amount of clean energy that you can't get presently from anywhere else. And it's complementary to renewables like solar and wind.
Yes, here in Boston, across the river in Cambridge, you're working on actually the potential of nuclear fusion, which would actually not have any waste. So who knows what the future brings? It's very exciting. We're getting close to our end of our time together. I want to talk about, of course, we're talking about energy production and alternatives for energy production, but there are other ways we could address CO2 in the atmosphere, one of which is perhaps taking it out with some sort of carbon sequestration. There doesn't seem to be much conversation about that. That seems like an exciting technological alternative. And even again, these topics are considered taboo. Geoengineering, that is to perhaps make the Earth a little less absorbent of sunlight and reflect a little more back into space. We do have some ideas on that. Why are we not going running towards these ideas? You know, we're a curious species that likes to solve problems. Why are we running headlong into those kinds of alternatives?
Yeah, the technologies of removing carbon dioxide from the atmosphere or taking it off the top of a smokestack in a fossil fuel power plant, these technologies are fundamental to the scenarios of the IPCC. So when you look to the future, there's a big bet that these scenarios are going to pan out. And you're exactly right that the amount of attention and research funding that's paid to them is a lot less than the role that they're expected to play in the future. That's going to have to turn around. I'm a big supporter of investments in innovation all along, from the basic research to the deployment and bringing to market, because it's through technology that will address this issue. So that's going to have to change. And who knows whether fusion or carbon capture technologies will pan out, but we can be sure they won't pan out if we don't invest in them. Geoengineering, I think, is a whole different category of issues. That involves not mitigating climate change, but trying to compensate for it by putting particulates up in the high atmosphere, by seeding the ocean or changing the albedo of the Earth in some ways by brightening clouds. From where I sit, and I wrote a chapter on this in my book, it's just a bad idea, because if we're worried about climate change due to human influences, do we really just want to add another layer of human influence on the climate system rather than removing that influence? We're not really good at anticipating the current consequences of climate change. Do we think that if we try to intentionally modulate the Earth, it's going to work out great for everyone? So it's kind of a Dr. Strangelove sort of path forward. And for me, it's just not the smartest move, given that we've already made progress, as you've said, reducing coal use in many places around the world, not everywhere. And we do have some optimism that we can continue decarbonizing the energy system.
Now, you and I were not invited to Glasgow this week. But let's say you were, and you were the head speaker, and you had the 30,000 or so people sitting in front of you, listening intently to your recommendations. If you had that speech and you were to speak to those leaders, what would you want to see as the, let's say, low-hanging fruit? What could we do that would be the most impactful and perhaps, if you can, most politically feasible, again, considering the globe, not just what we do in the US, but globally for nearly 8 billion people?
Yeah, one of the secrets of the framework convention process and COP26 in Glasgow is that the simple act of having the meeting is a success. It's not what people say or decide there. Obviously, global governance is very difficult. It's not binding, but the Paris Agreement creates an expectation that countries will act domestically, bring those commitments to a meeting like Glasgow, show them to the world, and there's a shared commitment to action. So what really matters under the framework convention process is what happens in individual countries. So holding the US government accountable to its commitments is really important. Holding China accountable to their commitments, really important. India came out just this week with a commitment to net zero by 2070, which some people have criticized because it's not 2050, but at the same time, India has a lot of poor people and uses very little energy compared to everyone else. It's a remarkable accomplishment. And so ensuring mechanisms of accountability to commitments is the key to keeping political pressure on this topic. The other thing I will say is none of this is possible unless there's a sustained and significant investment around the world in energy technologies. We don't have all the technologies we need presently, and we're going to have to invest much more in energy, similar to like what we do on defense, say, where the world invests, trillions of dollars in national defense. Energy is just as important, and we're going to have to realize that it's not just something that the market takes care of.
Indeed, I like what you had to say there. In fact, I like what you've written in many different forms. Where do you go for your information? Which scientists? You can't do all the primary research yourself. Which organizations do you find most trustworthy? And where, perhaps, again, I'm leading our listeners, where would they want to go to find, let's say, separate the signal from the noise?
Yeah, I mean, the climate space is enormously flush with opinions and views and so on. At the core, the IPCC is held up as the consensus view on science, impacts, economics. But again, you have to realize that the IPCC is not, stone tablets brought down from the mountain, and it can be criticized and improved. I hesitate to give a laundry list of groups. It's really, really difficult, I think, on climate, like many other global issues, for people to rapidly get up to speed on the topic. So I would say, pay attention, but be critical of the people on the most extreme sides of the debate. People who say, "Oh, don't worry about it; it's not a problem," or people say it's the apocalypse, the world ends in 2030. There is better knowledge out there, but how best to get it? Maybe that's something we can work on. It's really, really hard.
Well, I find you to be a wonderful steward in this space. You point me in the right direction to do a deeper dive if I like it. So I really appreciate the work you're doing, whether it be Twitter or Substack. Very, very useful. So before we end our conversation, I'd like to have you share with our listeners, how can they find you? How can they find your books and learn more about you and keep up with your finding in the future?
Yeah, thanks, Joe. Let me just say I appreciate the opportunity to talk about some of our work. I'm readily findable. I'm one of those academics who's very public. I'm on Twitter at Roger Pielke Jr., Pielke. I did a book about a decade ago called The Climate Fix, which has stood up pretty well on these issues. And people are welcome to email me. They can find me on my campus, colorado.edu. And if they have questions or feedback, I love to hear from people who take these issues seriously.
Wonderful. Well, that's a great way to end our show. I appreciate your time, Professor Pielke. This was wonderful. I hope our listeners learned quite a bit from you today. And thanks for taking time out of your sunny morning in Colorado.
Thanks, Joe. Appreciate it.
This has been another episode of Hubwonk, a podcast of Pioneer Institute, a think tank in Boston. If you enjoyed today's episode, there are several ways to support the show. It would be easier for you and better for us if you subscribe to Hubwonk on your iTunes podcatcher. If you want to make it easier for others to find Hubwonk, it would help if you would offer a 5-star rating or a favorable review. It also helps if you share us with friends and family. If you have ideas for me or suggestions or comments about future episode topics, you're welcome to reach out to me at hubwonk@pioneerinstitute.org. Please join me next week for a new episode of Hubwonk.